Right, question 6 is another vector question. It gives me the coordinates of 2 points, A here and B here. And the first part of this is to verify the value of the vector AB and determine the size of that vector, which is the length of this pipeline in the context. So remember that A to B, the vector from A to B, is essentially the vector from the origin to B minus the vector from the origin to A, and that's because AB is the same as A back to origin and then from origin to B. So this minus OA is the vector AO. So putting in the OB as the coordinates that we've got, it should be pretty straightforward. We've got 100, 200, 100 as OB, and then we're going to be subtracting from that OA, which is minus 200, 100, 0. And that is hopefully going to look very much like the vector that we're given. So that's 100 plus 200, 200 minus 100, and 100 minus 0 to give me 300, 100, 100. So that is verified. Find the length of the pipeline. So the length is just equal to the modulus of this vector AB. (300, 100, 100), and that is equal to square root 300 squared plus 100 squared plus 100 squared. Yeah, so that is equal to 3 squared, 1 squared, 1 squared. That's a root 11 times 100, isn't it? Which square root of 11 is not one that I'm familiar with, so let's chuck that in the calculator. That gives me 332 meters. Okay, part 2 then. Write a vector equation for the line AB and calculate the angle that it makes with the vertical. So the line AB is simply the position vector of A or B plus a parameter times the vector from A to B, or any integer multiple of it. So what's that going to look like? The vector equation for L is going to look something like this: OA plus lambda AB, which is this essentially. A as given is minus 200, 100, 0 plus lambda times AB, or indeed any integer multiple of AB. So I'm going to write it as 311. And that's fine. Calculate the angle it makes with the vertical. So this part of the vector equation of the line gives me the direction of the line. So the dot product of that and the direction of the vertical will get me what I'm looking for. If we look at the information given up here, OZ is vertically upwards. So what I can do is the dot product of 311 times the vertical, which is 001, is equal to the modulus of the 311 vector times the modulus of the 001 vector multiplied by cos theta. So that's fine. These two dotted together give me 1. Is equal to the modulus of 311 is root 11 multiplied by 1 multiplied by cos theta. So theta is equal to arc cos 1 over root 11. And chuck that in the calculator and hopefully get a sensible answer. make sure that the calculator is on degrees mode, because otherwise that's going to ruin my day. And I've got 72.5 degrees to the vertical, which seems all right. All right, question 6 done.